This podcast is brought to you by EnergyX. Are you tired of paying huge rates to the big cloud providers? Are you worried about being booted off a cloud platform if your company doesn't meet their ever-shifting standards? Ready to step up your data security and disaster recovery game? Well, ladies and gentlemen, your new cloud is ready. Introducing xCloud, the scalable, resilient computing cloud that is also actually affordable. It's high-performance compute for half the cost. HPC for HTC. xCloud from Red Team is opening a beta program for new cloud computing customers, and that means you, my friend. The xCloud is powered by the XMDC immersion-cooled modular data center from EnergyX. I've seen this data center in operation, and it is a total game changer. So if you want more information about the beta launch, go to the URL in the description. Type in promo code BETA, B-E-T-A, for 50% off of your first instance. And so the URL is going to be digitalwildcatters.com/EnergyX.
Branden, tell me real quick, what is Xstream Lift? It's actually pretty cool, man. I was there, when in the early days when you were talking about doing it, and been a little bit quiet about building it, and so now you're coming on the show and talking about it. So appreciate you coming here and taking the time, but tell me what you're working on.
Yeah, thanks for having me, Colin. So Xstream Lift is kind of bridges the gap between artificial lift and compression. And so what we do, and I'll get into the specifics a little bit later, but what we do is we build these high pressure gas lift units that are used for gas lift, don't need any valves down hole. And this technology, it helps you get more production than any other artificial lift method on the market. And it's like the simplest thing that you could even think of.
You brought me these stickers that says 4,000 PSI straight up your annulus. This is a good sticker.
Yeah.
We need to talk about that a little bit. We're gonna dive into this because I'm not a production guy, so we're gonna strip it down to some of the basics of artificial lift. But tell me a little bit about your background. You've been working in artificial lift and production all of your career. Am I right on that?
Yeah. So I grew up in Calgary. Got a degree in mechanical engineering in the U.S. and then went back and forth. It was kind of during the 2008 financial crisis that I was going to school, but the oil and gas business in Canada was doing really well at the time. So I was working in Canada, going to school in the U.S., kind of going back and forth. Interned with Canadian Natural Resources up in Fort McMurray in the oil sands. Did a 8-month co-op term with them. And then when I was graduating, I interviewed with a lot of different companies. And one of them was EOG. And I interviewed with them in the US, and they were always looking for Canadians to send up to their Canadian division. And when I talked to the Canadian guys, they basically had this little field in Waskata, Manitoba, which is like 15 minutes away from the U.S. border to North Dakota. 140 people in this town, and no one wanted to move there. So they found me and asked me if I wanted to move there, and I kind of snuck in the back door at EOG, kind of non-traditionally.
Yeah.
Didn't go through like the big, internship, like 2 internships and all that stuff. I said I'd move to this little town no one else wanted to move to, and I moved there. So
they needed a warm body in this small town, and you're willing to do it.
Exactly. So it was a field of like 700 rod pump wells. I spent a little bit of time in the office in Calgary, and then they moved me out to this little town in the middle of nowhere. I actually had to go across the border into North Dakota to go to Walmart.
Oh, really?
Yeah.
You had to go into a whole other
country. I had to go through the border crossing to go get my groceries every week. And I even had a P.O. box in North Dakota to get Amazon packages because I couldn't get them to my house in this little town.
What town in North Dakota did you have to go to?
Botno.
Okay. Yeah, that's, I've been to North Dakota several times, and, up there, you can get in the middle of nowhere, pretty
Dude,
quick. And
having lived up in those remote places, and even now I live in Midland now, but you spend time in these places, you're like, how did people homestead these places?
Yeah, no.
I have no idea how people survived.
That was my biggest takeaway when I spent a month on the North Slope of Alaska. I was like, how do the Inuits live up here? I was like, it doesn't make any fucking sense to me how humans were able to do that. And yeah, I don't think most of society, I think it's something that we're privileged to working in oil and gas, that you truly get to be out in the middle of nowhere and gives you kind of perspective.
And it's always in the extremes, like either like -40
yeah,
or colder or like 110 or hotter.
What I've learned is that we never drill for oil in nice places. It's always extremely harsh. But even, in Texas, man, I'd spend time out in the Eagle Ford, and, I'm 2 hours away from pavement on the Mexican border. I mean, even in just our home state, I'm like, dude, you can get out in the middle of fucking nowhere, and, parts of West Texas.
Well, think about anywhere between Pecos and Carlsbad, man.
Yeah.
I mean, that's...
Yeah. So, that's funny that you can kind of paint it in that extreme. It's like I had to drive to a whole nother country and go through border crossing to even get groceries.
Exactly. And so started my career up there, field-based production engineer. They handed me 3 workover rigs and said, here you go. I had no idea what I was doing. The company men would call me and be like, hey, wells on a vac, this is what's happening, all this. It was just little rod jobs, but 3,000 foot deep, 3,000 foot laterals, so 6,000 kind of TD wells. And I just learned by doing. I mean, that's how I learned. I wasn't fantastic at school. I spent all my time in college in the math tutoring lab.
Yeah.
But I got through it. And so I just learned real well hands-on, and I've been fortunate that I've always been kind of field-based in my positions and been able to touch things and see things and be on the rig and all that stuff. So I kind of, that's how I learned the best.
Which is actually, that's an interesting point, because, the time that you came in the industry, it's kind of the rise of shale and horizontal, and you had a lot of engineers that, companies like Pioneer and EOG were catering to engineering students coming out of school, right? And kind of bypass that field experience, which is kind of like an old school thing of like, you're an engineer, you go out to the field. But I'm just a big believer that hands-on, seeing it, like, sorry for all the engineers out there, but what you learn in school, it's completely different than what happens out in the field and actually seeing it.
There's no parallel for real world seeing and touching things.
Yeah. So sounds like, you're fortunate in that aspect. And, I love that you ate glass for eat shit, whatever you want to say, whatever you're eating, but to go up there when no one else wants to. That's where the opportunity's at, right? Is doing the stuff that no one else wants to.
So EOG then moved me down to North Dakota. It was moving south for me. There's a lot of, how these, a lot of these A&M kids come out of college, and the first thing they do is get married between when they graduate and when they start their jobs.
Yeah.
And to put it, there, a lot of wives from Texas, from A&M, weren't happy up in North Dakota. So they sent some Canadians down to North Dakota, where we were a little bit more used to the weather.
Yeah. More acclimated to it.
Spent about 5 years with EOG up in that area, doing a lot of really cool things. And I got really, again, that was field based. I was in the Stanley office, right in the middle of the wells. I had a big group of wells that I was in charge of. Back then, it was when the Bakken was absolutely blown and going.
Yeah.
Like it was busier than the Permian was at the time. In like the early 2010s, right?
Yeah.
And so I got to see a lot of action and a lot of stuff really quick. We were using a lot of ESPs at the time. I got my hands on ESPs. I had some really good mentors at EOG, and also just a lot of wells and a lot of activity. So I saw like the volume of stuff I saw was so much, so fast.
Yeah.
Because we were, in my area, I was doing 60 new drills a year or something just in my one area, right?
Yeah.
And we had, hundreds of ESPs in the field. And I kind of took interest in that and took it upon myself to like become good at that and become a technical expert for ESPs. And so that's kind of where this high pressure gas lift journey started, because ESPs are like super, they're good at producing a lot of fluid and getting really good drawdown, but they're really complicated electromechanical machines and have thousands and thousands of moving parts, and you basically plug in, like, you set it 10,000 feet deep and plug in a 10,000 foot extension cord to surface, right?
Yeah.
And these wells, there's so much that can go wrong. And it's harsh conditions, right? Like, you have your wellbore deviations from drilling these long reach laterals and trying to get your well spacing on from like a multi-well pad and getting your well spacing down hole. And you got, like, you're producing massive amount of sand and solids.
Yeah.
And especially in the Bakken, like, it's naturally fractured up there, and those wells just seem to give up so much sand for such a long time.
Yeah.
And then your GORs are constantly going up. And, like, we're talking about always drilling in remote places. Like, the electrical infrastructure isn't good.
Yeah.
And the first word in electric submersible pumps is electric, right? So like, power quality isn't good, but everybody uses and still use ESPs because they're really good at moving a ton of fluid really fast, right?
Well, that's something I actually didn't appreciate until last year. And actually, I think it was Dom that was talking about it. Was talking about quality of power,
Mm-hmm.
and I didn't realize or appreciate how much production engineers within these EMPs understood or were paying attention to electricity quality coming from a substation. And that's something that I don't think is, like, super appreciated.
We're doing, especially with ESPs, dude. When I was in North Dakota, when we'd have, like, a bunch of ESPs go down and we'd start them all back out, the town of Parshall would have a voltage sag, and people had gen sets because we were pulling so much power in the oil field from ESPs when you'd bring a bunch online at a time.
That's insane. So let's take a pause here real quick, and let's do some oil and gas 101 for everyone out there. Obviously have a lot of production engineers here that know what an ESP is and how it functions and operates, but I have a lot of people, from downstream, midstream that don't. Can you just give us a high level overview of how a ESP actually works?
Yeah. So an ESP is a centrifugal pump. Basically, it's kind of like if you have a turbo in your car, that little impeller in your turbo that gives you your boost, that's a ESP stage, basically. So what you do is you take those stages and you stack hundreds of them on top of each other. So the different components, you have your pumps, like starting from the top down, on your downhole stuff, right? You have all your pumps, which are made of ESP stages. And like I said, you have hundreds of them because each one of those stages produces so much head to lift fluid. And if you're 10,000 feet down, you need to add enough to get 10,000 feet of lift to get lift to surface, right? And then below that, you have, like, your intake and your gas separator where fluid comes in. And of course, these wells produce oil and gas, so you have to have some sort of separation mechanism to try to get as much gas out of there. Because if you get too much gas in an ESP, it's like when you're making a protein shake or making a smoothie in your blender, and it sucks in a pocket of air, and then it spins real fast and it doesn't blend anything. That's essentially what gas lock is inside an ESP when you get too much gas in there, where you won't be moving fluid through there, and that pocket of gas will make it so it spins and it's not actually doing any work, right? And then you get to overheating and things like that and burning up motors. And then underneath your intake and your gas separators, you have your protector or your seal. And what that is, that's a barrier between where your fluid comes into the pump and then your electrical motor, because, electricity doesn't like being in water, right? So you're downhole submerged in water, and you have to separate and make sure, your wellbore fluid doesn't get into your motor and contaminate your motor. So you have a protector, or sometimes called a seal, that has a bunch of chambers that filled with oil and that communicates with the motor oil, to make it so that it's really hard for wellbore fluid to make it into the motor and short out the motor. And then you have a plug-in to your ESP called a pothead, and that plugs the cable in, basically however deep your well is, 6,000 foot, 10,000 foot extension cord to surface. And then on the bottom of the motor, you have a sensor that measures the temperature of your motor, the temperature of the fluid, and the bottom hole pressure.
To your point, I mean, you can tell this is a complicated piece of machinery, and it's ran down, 10,000 feet
And these
in the
strings
ground.
are 50 to 100, 150 to 175 foot long, and each component is no longer than 20 or 30 feet, right?
Yeah.
So you're on the rig floor making, lots of connections. Like
Yeah.
the motor itself is, because electric motors increase with horsepower in diameter. Like they increase in horsepower like squared in diameter, but in a 5.5 casing well, 5.5 20-pound casing well, where you have 4.78 ID, like 4.65 drift.
Mm-hmm.
I mean, you're talking about a 4.5 inch motor,
Yeah.
right? And in order to get the horsepower you need 400 horsepower for some of these new wells.
So you just got to stack a bunch of them.
You have two 30-foot motors you're putting on top of each other, right? With all the electrical connections that have to go together just right on a rig floor in the middle of North Dakota at -40, or in the middle of West Texas at 110 when a haboob's coming in, right? And so like the rig floor is not the cleanest place either. So you have like all these electrical connections, and you're making connections to mechanical and electrical connections, like 5, 6, 7, 8 of these connections to stack up this string that's 150 feet long, or sometimes 175 feet long, not even counting the bottom hole assembly or whatever sand protection you put on top of it.
Yeah.
And then you're running in on tubing and spooling the cable and spooling chemical injection line while you're running in, and either banding it to the tubing or you're clamping it. And just, there are so many quality things, like so many things that can get damaged or nicked, that can reduce the reliability and runtime of the ESP, that you really have to do everything really, really prudently and really right and follow procedures to get the best chance for it to run the longest. And in the oil field, that's not always the case, right?
It's never the case.
No. So
like, that's actually fascinating to me, because I've never seen an ESP assembled, and spent a lot of my life on workover rigs and running tools, but I've never actually seen an ESP built. And so having you articulate this, I'm like, that sounds like a nightmare to be doing that. And even if everything goes right, just downhole conditions are rough. Mm-hmm. And so, to kind of illustrate this for everyone, what you're talking about with the horsepower and ID of the casing issue, it's like your casing's downhole. You have whatever ID you have, that's what you have to work with. And, you're talking about, fitting something that's 4.5 inch and a, 4.75 ID. I mean, that's not a lot of space in that annulus. And then you're running cables and things of this nature. And so, things get nicked up. And so, that's just, I didn't realize that it was that delicate and intricate of a process to assemble those and actually get them down whole and working. So that's, no, thanks for sharing that. And so, all right. So when little side tangent from your story, but that was great.
So I was at EOG. I was doing a lot of ESP stuff. Like I became one of the, for the Denver division, one of the, the ESP guys there, and traveled around to a lot of the, all over North America, all the ESP shops doing, quality stuff, teardowns, audits, designs, all that stuff. And so so all the production engineers will appreciate this. When you're a production engineer, you're always getting pressure from management to produce more, right? Mm-hmm. We want more production. Yeah. But you're also getting pressure to spend less money. Yeah. And usually those two things can generally, they go in the opposite direction. If you're trying to produce more, you end up spending more money. If you want to spend less, you're gonna produce less. So you're always trying to find, like, especially with ESP reliability and how expensive they are, like these are hundreds of thousands of dollars, when you buy one, plus your workover costs and all that stuff. So, so you're always playing this game of like, okay, we want to change artificial lift type. So we'll go from ESP to gas lift, and then, or ESP to rod pump. And you're constantly trying to use these other artificial lift types to get a lower cost profile than your ESP, but still match the production. And it's very hard to do unless your well's down at 500 barrels a day already, or under 1,000 barrels a day. Yeah. And so we were trying to go to gas lift, and conventional gas lift just couldn't get us there, right? So we're trying to figure out a way to get away from ESPs, but not sacrifice on the production.
Yeah. You wanted your cake and to eat it too.
Yeah, exactly.
Go into gas lifts a little bit and give us a rundown like you just did on ESPs, on gas lift, and why you guys were trying to go to that. Sounds like a cost basis.
Yeah, so gas lift is generally on the capital side. You spend all your money on surface, on like injection lines and compression and everything. But on the OpEx side, it's extremely cheap. All you have is tubing in the hole, right? Just think about tubing. Sometimes you'll have a packer down hole. Sometimes it'll be packerless, and you'll put gas lift valves in there. And basically, gas lift valves are these little points of entry down the tubing string that are spaced out, and they're pressurized so that they open and close at a certain pressure. And then you get a compressor, and you inject gas generally down the casing side, the annulus between the tubing and the casing, and down into one of these valves. And depending on how it was designed, it's designed to get it like in the top valve, and as your bottom hole pressure decreases, then that top valve closes and forces the gas down to the next valve. And then your bottom hole pressure decreases as you produce more barrels, and then that valve closes, and you work your way down your valve string, or down your tubing string on your valves. And then all you really have is tubing that your production is going up. So it doesn't matter if you're producing sand, doesn't matter if you're producing plug parts, doesn't matter. The more gas the well produces, the better, right? So you're not fighting gas like you are in ESP.
Yeah.
And then if your well's deviated, it doesn't matter because you don't have cable in the hole. You don't really have anything
it's much more of a mechanical system with fewer points of failure.
So actually gas lift does really well in all these areas where all these tough things that unconventional wells throw at you, right? Like everything that ESP is weak at, gas lift does great. But the problem with gas lift is you can never get, especially on new wells, it's really hard to get the same production as ESPs. And there's two reasons. The first reason is you're limited on your injection depth. So traditional compression is limited to roughly 1200 psi injection pressure, sometimes as high as 1400, but the rule of thumb is generally 1200 psi.
Okay.
And it's my opinion, this is just me, like gas lift valves exist because compression traditionally has fallen short. So on a high bottom hole pressure well, you get a compressor, it outputs 1200 psi, and say you can only force your way a quarter of the way down the hole, right?
Mm-hmm.
Because the bottom hole pressure is too high to get all the way down.
Yeah.
So that's where you put a gas lift valve, and then you just work your way down from there.
Yeah.
So gas lift works by lightening the fluid column. So you inject gas into the tubing, and it reduces the density of the fluid in that tubing. So the pressure of the well can flow it on its own. And then as the bubbles rise and they expand, there's some lifting effect there as well. But think about, you have like a 10,000 foot deep well, and you're only reducing the density of like the top 2,500 feet. That's what conventional gas lift does.
Mm-hmm.
And then conventionally, you're injecting down the casing and producing up the tubing. And that 2 7/8 tubing on the inside is only like 2.441 ID. And so it's really small. Like take a tape measure and measure out 2.4 inch radius or diameter. And there's not a lot of flow area there. And so what also happens is you bump up against hydraulic friction, where the friction in the tubing, once you get to a certain flow rate, is so high that you can't get above that flow rate. It's like terminal velocity falling down a plane with wind resistance, right? Like you hit a certain velocity, and due to wind resistance, you just stay at that velocity. With conventional gas lift up tubing, you hit like hydraulic friction limitations, and you can't produce more than that because the dominant force is friction.
Yeah.
And so you're limited by both injection depth and friction.
Yeah.
So
with conventional gas lift system, you're essentially going and doing it in sections through these valves, you know, 2,500 feet, whatever that interval is. Yeah. And so this parlays into what you're doing with Xstream Lift, obviously. I'm just going to take a guess here. You saw this issue and said, hey, it sounds like to you're like, the actual problem is on the compression side and not having enough force. And then I'm also, 4,000 PSI straight up your annulus. I'm like, all right, kind of start connecting the dots and seeing where this is going. And so, what was your take on solving
Yeah,
the
so
issue?
I can't take full credit for coming up with the idea. So, but what happened was when I was at EOG, they were really good at facilitating cooperation over the entire company, and so we would get together like every year, as like production engineers from all the different divisions, the different basins around the U.S. and in Canada. And we would like have like a week-long or 3-day workshop on some topic. And it was usually some topic that one specific division was strong at, right? And we have it in that division. So one year in the Denver division where we ran a lot of ESPs in the Bakken, we had a 3-day workshop on ESPs. And we would have like a ESP training from some, technical professional that trained us on ESP stuff. And then we would present to each other and share what we were each doing in our respective areas and kind of brainstorm and learn from each other and, all those things. And so another one we had was rod pumps early in the Eagleford's life. They would run a lot of rod pumps. We had a rod pump one in the Eagleford. And in 2015, around just before Christmas, 2015, we had one in Tyler, Texas, and it was around gas lift. And so really that workshop meeting was the genesis of high pressure gas lift today, where we all got together and we were presenting to each other the issues we were having with ESPs. Like in the Denver division, with gas lift. In the Denver division, we were trying to go from ESP to gas lift and couldn't get the rates. Barnett had these older, Barnett wells that were low pressure, and they were able to not run any valves and do pour boy gas lift around the end of tubing. And then you had, the Eagleford that was moving away from rod pumps and going to gas lift and was having, gas lift valve failure issues and things. Then you had the Permian that was just starting to blow up and they were doing GAPL on old wells and other things. So we're all talking to each other and presenting to each other and brainstorming together. And basically what came out of that meeting was, if we had compression with higher discharge pressure and Tyler, Texas had these new Buddha wells that were pretty good wells, and they were doing annular gas lift, so injecting down the tubing, producing out the casing. And so we kind of put all these things together as a group, and we're like, man, if we just had enough compression, like high enough discharge pressure that we didn't have to use any gas lift valves, then we would get rid of any issues with gas lift valves. Then if we could go down the tubing, produce up the casing, then we get monster rates because you'd get rid of that friction, because in the casing, that casing area between your tubing and casing is almost 3 times bigger than up your tubing. So you get rid of any friction limitations. And so through that brainstorming, all these things came about. And so we each went back to our respective divisions and solicited compression companies to build compressors, and almost nobody wanted to do it.
Oh, really?
Yeah.
Why do you think that was?
Traditionally, compression likes to build units that won't sit in the yard if they don't have an application. So they build things that will work in a lot of different scenarios, right? So the same machine they might be able to use for gas lift, going to multiple and sending gas to multiple pads as in like a gas plant, or for midstream, right? Like they don't want it in the yard eating grass.
Yeah, they want a general use compression system that they can utilize across different assets.
And in the industry, the downhole gas lift guys and the compression guys don't talk. Like there is no service company that does both, right? Like the downhole gas lift guys just say, give me compression, tell me what it's going to be, tell me the injection rate and the pressure, and I'll design for that. And the compressor guys are like, just tell me where to drop this unit off. And if it's not on skid, I don't care about it. All I care about is what's on my skid, and that's what I deal with.
The opportunity always sits at the intersection of things, and I see this all the time
Yeah.
in different businesses. And so it's a really interesting intersection right there. It's got these two parties and they don't talk to each other and don't understand, the each side of the. I gotta go on a small tangent real quick. You mentioned EOG's Buddha wells. Did you ever see our podcast episode Buddha Gate back in the day?
I listened to that.
If you go search EOG Buddha, like Digital Wildcatters comes up. And so now that you mentioned that, it's just further evidence that EOG's sitting on a huge Buddha play. But
I have no insider knowledge. I haven't worked for them for this is 7 years.
This is Branden's disclaimer. So with Xstream, are you guys building the compressors? Tell me, like what the actual product and services.
Yeah, so we build this booster compressor.
Okay.
So it's just a small gas lift compressor, 3306 NA engine, which is a pretty normal size for a single well gas lift, right? But we engineer it in a way where we take the discharge pressure gas from your conventional compression at like 1,000 pounds or 1,200 pounds, and we can boost that up to over 4,500 pounds.
So you're actually stacking this up with conventional compression systems.
Yeah,
okay, cool.
Exactly.
Cool. So for y'all, from a business model perspective, you go, I'm assuming that you work with the EMPs directly in their engineering teams.
Exactly. Yeah. So to back up a little bit, I left EOG shortly after, like in 2017, I left EOG. We had done some high pressure gas lift pilots with a couple companies that decided to, try this out and build a few of them. And SM poached me and brought me down to Midland right when they bought that Howard and Martin County stuff. Mm-hmm. And so when I was interviewing for that job, I had mentioned this high pressure gas lift stuff that was really, really nascent. And there was some interest from my boss, who ended up being my boss, Nathan Loama over there. And so that's something that we attacked and wanted to do at SM as they developed this field, because we started with, I walked in there, they had 30 wells, 30 horizontal wells. By the time I left, it was over 330 wells, like 3 years later. But again, they started with ESPs, and they initially reached out to me because I knew ESPs. And so I came in, was an ESP guy, did all their artificial lift strategy for these, for that new area. And then we did a pilot test with high pressure gas lift to compare against ESP in Wolfcamp A and Wolfcamp B wells, because those are the gassier wells out in the Midland Basin. And then, so I did that pilot, and then I wrote an SPE paper about it in 2018. And it was called like single point gas lift. I forget exactly what my own paper is called.
That's how much you care about the paper. You don't remember
I
what
do
it's
care
called.
about it. It's basically like single point high pressure gas lift beats ESP and Permian Basin pilot test or something like that.
Yeah.
Right. And so basically we had a pad with a bunch of ESPs on it and a couple of high pressure gas lift wells. High pressure gas lift wells beat the ESP like huge. And then I was able at SM to roll this out like really, really large scale on a, with our development, and do it on all the Wolfcamp A's and Wolfcamp B's in that area. And we ended up just beating IP records, like Midland Basin IP records with these high pressure gas lift setups.
Wow.
And so when I'm interacting with a customer, I'm not just a compressor company coming in and being like, hey, here's a package, take it and do what you want with it, right? Like, I have enough context and have done this as a production engineer that I'm like, okay, they ask for my feedback, and they're like, so what do we need to do to make this successful? And so I'm able to guide them through bottom hole design, through the wellhead design, flow lines, all the way to the facility as a system to complement our high pressure gas lift unit to make this project as successful as it can be and maximize the results.
That's really interesting when you have someone like you that's an engineer, that's a subject matter expert on a topic, saw this problem firsthand, developed a solution for it, and now being able to scale that to other oil and gas companies. And it's like, hey, it's not just a compression company that you can just we'll serve up a compressor, booster on a skid. Like you actually have domain expertise and the problem that they're trying to solve. And so that's super interesting. When did you start the company? It's been a couple years now.
Yeah. So we started in 2020 in the depths of COVID and
Yeah.
negative oil prices.
Yeah. Yeah. I relate to that. You know, it's a awesome time to be starting a company in oil and gas.
Yeah, we built the first. So I met my partners through the paper I wrote.
Yeah.
I mean, honestly, had I not written that SP paper, we probably wouldn't be here right now.
Awesome. I love to hear that, you know, because I tell everyone content is the highest form of leverage of our generation. And it doesn't matter if you're writing a blog post, if you're writing a white paper, if you're recording a podcast. Good things come from creating content, and so that's awesome to hear.
Yeah. So met my partners. We pulled some cash, built the first unit with our own money.
Nice.
On spec with no customer, and then found a customer for it. That was, by the time we got that unit out, it was spring 21.
Yeah.
And then got
pretty
that
quick
unit.
timeline there.
Yeah.
I mean, get prototype built and field trialed.
Mm-hmm. And then we got our first big order with an anchor customer, and then, begged a bunch of friends and family for some money, and friends of friends and friends of family. And
Chuck Yates likes to call it friends, families, and fools.
Yeah, exactly. And we're fortunate. We had a lot of our, and they're still all our equity partners. They're all, we're entrepreneurs, OFS entrepreneurs themselves, and have successful businesses now, and really liked what we were doing, and really took a chance on us. And
which, there's something to be said for that as well. Digital Wildcatters, all of our capital that we've raised has come from angel investors in the energy industry. And it's good having champions on your side that, they have networks, they have people that they can introduce you to, and then just insight on building successful companies. So I'm sure y'all have seen some element of that as well, going through that process. Talk a little bit about what I'm curious about is you'll build this prototype and you get it field tested, year and a half, sounds like. A lot of companies out there struggle with the field tests and the pilot, and EMPs, the way that they adopt technology is they don't give a shit how cool it sounds. Who else is using it? And so tell me a little bit about that. And you don't have to go into details about who the operator is or anything like that, but how are you able to convince someone to run this in a well so quickly? So
by the time we'd done this, there had been a couple other compressor companies that started building a bunch of these same units off the back of, the success we'd had previously at where I'd worked before. And through the paper that I wrote, it was starting to gain some interest, and a lot of people were doing it. And so you have, the oil field's a small place. A bunch of these engineers all know each other at different companies. So you're having beers, you're at some event or some, and you're talking with your buddies. And one guy's like, somebody's tried high pressure gas lift and somebody else hasn't, or they're talking about what they're doing at work. And so, it wasn't super radical by that point that it seemed like just something so far-fetched that was hard to do. Like enough people were doing it that it wasn't too much of a hard sell. And a lot of the work I have is just through relationships that I built over the years with other friends at oil companies that are other engineers, right? And so I think those relationships go really, really far.
Yeah, I mean, that's one thing that's a constant in every business is the soft skills and the network. I mean, you have a guy like you, super technical engineer, subject matter expert on this on this operation, but ultimately none of that matters if you don't have a way to go commercialize it and sell it, right? And so being able to rely on the network that you've built over the years, and I think also just kind of speaks to, I love how you said that the market was actually already kind of accepting of it because of the white paper you wrote, and people were talking and trying things. Like, this is something I think about a lot, is sometimes you have to condition markets and condition industries. And that white paper that you wrote was kind of setting that foundation for you a few years down the road because, hey guys, we've done this and had success with this, and you start getting other people thinking about it, and now they're accepting of the idea. And so when you go to take your product to market, you're not having to fight that battle of educating them and conditioning them for it. So
another thing that made us super successful, and I've done a couple entrepreneurial ventures now in the OFS space, is your partners that you go into these ventures with need to be really strong, and you all need to have your expertise and complement each other really well, so that like 1 + 1 is 10, or right, not 1 + 1 is 2.
Yeah, we need exponential math here.
Yeah, so I have to give a lot of credit to my partners, because everybody within our company has really strong operational and field backgrounds, and has spent a lot of time, providing services to oil companies or working at oil companies. So that's something that's contributed a lot to our success, is just knowing what we're talking about in the field.
Yeah.
And being able to execute in the field and not screw up too badly in the field. Or if we do screw something up, being like, okay, look, we messed up. We got this. We know what went wrong. This is the fix, and we're fixing it right away. It's never going to happen again.
Yeah. Picking the right partners can make or break you, right?
Yeah.
So it has to be an overwhelmingly yes. This is the right partner. Like you said, complementary skill sets. That way, when you're building a company, man, it's fucking hard, and you have to cover a lot of ground.
Everybody says that, but you don't know until you've done it.
Yeah.
That's like, I even think sometimes I'm like, man, where would I be if I just like stayed at a cushy engineering job and just like got my salary and my 5 weeks of PTO or whatever, and my stock options, right? Like, but I think about it, I'm like, I wouldn't trade that for anything, man. Like, I'm having the best time of my life.
I think about this all the time because, I'll be watching my friends' Instagram stories, and, they're all investment bankers and have done really well for themselves. And I always watch their Instagram stories. I'm like, God, am I an idiot? Like, why do I want to build companies?
Yeah.
But it's the love of the game, right? And, hopefully you have a good economic impact or return for your efforts. But I never like to talk like, there's a lot of people like, oh, building businesses is hard. Like, that's not part of my rhetoric. I don't like talk about that a lot, but it's funny. I was listening to these 2 podcasts from Mark Zuckerberg this weekend, and even he was talking about, he's like, building businesses it's tough and it's challenging. And like, the thing is like, you never reach a point where it's not hard or challenging. It's not like, oh, I've made it. Like, it's a business is a living organism and continues to evolve, and you have to iterate over time. And so making sure that you have the right team in place to do that is super critical. And
just pick your hard. I mean, life's hard, man.
That's life is hard. So yeah, I mean, it's hard regardless. And so I've had a couple of friends recently, but overall, throughout the years, I have a lot of engineers that come to me and want advice, like, hey, should I go start a company? Should I join a startup? And like, I had a real conversation with a friend the other day. He just had a kid, and he's at Chevron, and he's like, here's my salary, here's my bonus, here's my pension, other benefits. And I was like, dude, to be honest, I said, it's not a bad life.
No, it's not.
It's not a bad life. There's lots of people that have worked at majors and become multimillionaires just from doing that. And really don't have to work that hard to make that happen. I was like, it's not a bad life. I was like, you really got to ask yourself, like, why? Like, you're not going to go to a startup. Like, it's not going to be easy. You got to pull your weight.
Mm-hmm.
Who knows if you'll make any money from it. But those are the types of things that you have to ask yourself. It's like, why am I doing this? And so if it's from a pure economic standpoint, it's like, hey, the risk adjusted safe way is to go get a good job.
There's a lot of economic pain before hopefully you get the payout at the end of it, right?
I've had a lot of economic pain. I'm hoping someday that I don't have that economic pain, but it's not today. But man, this is super fascinating. I hope one, you gave a masterclass on artificial lift. I was setting you up for an alley-oop there, and you took it to the rim and dunked it. And so there's going to be some awesome content coming out of that on artificial lift 101. But for you, as we're signing off here, what's your ask? You looking for customers? You looking for investors? What's on the path for you guys?
We're just at a point where we're starting to scale, right? So I felt like, we'd been talking for a couple of years about getting on the podcast, you and I.
So a couple of years in the making.
And I felt like it was the right time now. We're at the right scale and have established ourselves well enough that I think it was the right time to do something like this and kind of broadcast us out into the world.
Oh man, this is exciting stuff. Fortunate thing for me is I always get to see these things, from, the sidelines, and saw you in the early days, and, you can tell people, but I was always pushing you, like, come on the podcast, come on the podcast. And you're like, not until we're ready. And so, I'm excited for you guys that you're at that point. And before we end this podcast, this is your time to shine your pitch. Tell me why people should use Xstream over any other competitors out there.
So, Our thesis is threefold: more oil production for less operating costs and fewer emissions. So what I mean by that, so more oil production using high pressure gas lift over ESPs or conventional gas lift, lower operating costs with our compressor package is called the Scout ULM. So lower operating costs with our Scout ULM. We've done so much engineering in-house and manufacturing. Our package is honestly the best package out there. And our mechanical availability is the highest in the industry, as well as we get the highest throughput out of any competitor. So where one of our competitors would be at 1.8 million a day injection rate, we're up to 3 million a day on our conventional two-stage machine.
Wow. Almost double.
Yeah, almost double. And then third is our fewer emissions. So we have a patented technology called our Ultra Low Methane technology. We abbreviated it ULM. It's on the back, our Scout ULM. And what that Ultra Low Methane technology does is four things. Number one, it eliminates fugitive methane emissions by eliminating the use of process gas. So we have electric starters, no use of process gas on starting up. We've gotten rid of the use of process gas for pneumatic controls. So there's no process gas for pneumatic controls. The second part is where we can't eliminate it, we capture it. So we capture fugitive methane emissions off both the compressor frame and the engine itself. So we capture those emissions and then feed it back into the intake to burn as fuel. And then the third thing we do is we get rid of sustainable operating practices, right? So we usually when a unit goes down, you have to restart it. You have to blow down the unit to atmosphere. So we've gotten rid of that. You don't blow down the unit to atmosphere. You blow it down through the blow case to where you dump like your liquids and stuff out of your scrubbers. And so you no longer are blowing, straight methane out into the atmosphere either.
It's pretty cool to hear about how y'all are capturing methane and dumping that back in as fuel as well. And so it sounds like some pretty intricate engineering
And honestly, there's so many companies out there that they're identifying methane leaks, right? Whether it's on tanks or flares or using cameras, so many companies out there are identifying methane leaks. But how many companies are actually doing something about the leaks, right?
Yeah.
So what we're doing is we're identifying the points where you have these fugitive methane emissions, and we're capturing and eliminating them, and we're measuring them. And so when you get down to it, when you look at from a CO2e basis, scope 1 plus scope 2. So what does that mean? Scope 2 emissions are the emissions associated with that specific thing. And then scope 1 emissions are upstream. So, or no, it's the other way around, right? So scope 1 is that your thing that you're using.
Yeah, it's your direct. Yeah, your direct emissions.
And then scope 2 are the ones straight upstream. And so if you look in an electric package, a lot of people are electrifying compression right now because of emissions. When you look at an electric package, you can't just ignore scope 2 emissions, right? You have to take in, you may not be having any direct combustion emissions on your package, but without the ULM technology, and if you have an electric compressor, you still have fugitive methane emissions from all the other components, right? And then you have to take into consideration what the makeup of that grid power is. And when you look at both scope 1 and scope 2 emissions, our engine, normal natural gas engine 3306 NA package is within 5 to 8% of the scope 1 and scope 2 emissions CO2e as an electric package.
Oh, wow. So, it's fascinating hearing about that, because the engineering in itself is already tough in terms of building a solution for a problem in artificial lift, but then taking in the emissions factor as well. And I love how you said it. There's a ton of people out there that are monitoring emissions and identifying emissions, but actually creating solutions that capture them and solve them. And so super interesting to hear about how you guys think about that.
And then you get back to, like, we talked about electrical infrastructure earlier with ESPs. Like, one great thing about gas-fired natural gas compressors is you don't need electricity. And so if you start setting all your compressors now are electric, you're dealing with the same electrical issues as you do with ESPs, with power quality and power distribution and building out the grid and things like that. And we are building a certain percentage of our fleet electric, but in these remote locations, it's just not feasible. You can't put all electric compression out there.
Yeah.
So
combination of
you have to have a good, clean combustion option that is also, environmentally sustainable.
Yeah. So engineers that are listening to this, where can they find Xstream on the internet? If they're interested in y'all's solution, find you on LinkedIn, find you online.
Yeah. Find me, Branden Pronk, on LinkedIn. Find Xstream Lift on LinkedIn. It's spelled, we spell a little bit weird. It's XSTREAM Lift, or XstreamLift.com.
If you're watching video, here's a sticker of it, Xstream Lift.
There you go.
We'll drop a link into the show notes. Check it out. Find Branden on LinkedIn. Hopefully someday soon Collide. If y'all aren't over on Collide, Branden, thanks for coming on, man.
Thanks, Colin. Appreciate it.